Okay, so I've not made a video for this channel in a while, or I haven't made a video to put on YouTube at all. So I'm making an off-the-cuff video about a project I did a while ago, and I thought it was just a little interesting to make a video about. So my friend showed me this game called Set in real life with cards. I'll explain the rules of Set afterwards, and then they also showed me that they were addicted to like a clone of the Set on their phone. I thought this was an easy game to automate, so I decided to automate it. I actually chose a different version of Set because although this has high scores, they're not online, so I didn't want to cheat someone online out of high scores. But first, if you don't know the game Set, which I wasn't aware of, I'll just quickly explain the rules. You get presented with cards, and then the cards that you're presented with are guaranteed to have a set. Each card has 4 properties: the number of shapes, the type of shape, so number is either 1, 2 or 3. The type of shapes is the squiggle, the diamond or the oval. The fill, so if it's empty, if it's full, or if it's striped, and also the color, so the green, the red and the purple. So you have 4 properties, each of these has 3 values. You find a set if 3 cards either have each property being all the same or each property being all different. So if you want to find sets, what you want to do is on a computer you can check 1, 2, 3, and then if that doesn't work, if that's not a set, you can go to the next one. Oh shit, that was a set, sorry. So you check the first cards, and then if that's not a set, you check the next card, and then the next card, and the next card. So the number of combinations there for 12 cards, which is what you usually have, is 12 choose 3, which is 220. But there is a better way, or possibly there's a better way of solving it, which is you check 2 cards, and then you find what the card that should match this is. So the card that should match it should be green, it should be an oval, it should be striped, and there should be one of them. So you then check the rest of the deck, see does one of these shapes, or does this shape exist? If it does, you click it, and then you've done. So that's how you find the set. And because there are less combinations of like 2 cards in 12, because 12 choose 2 is 66, but the comparison is a little bit more expensive, so I just wrote a quick version of Set here that automated thousands of games and just took the average. And we can see here the average games. If you want to find all sets on a page for each number of cards, actually in the game you can only have like 12 or 15 or 18, like any, or 9 or 6. It's only a number of 3, but let's say you can have 10 or whatever, it doesn't matter. So to find the average time taken to find all sets versus the number of cards you have, you can actually find that the brute force method is faster than finding the missing card method. But we actually don't want to find all sets, we want to find only one set, and then click it. So if we do that, go here, we see that again that they're very similar, but for high numbers of cards the missing method is a little bit better, and for most games it's either 12 or 15 cards. So I decided to use the missing method or the brute force. It doesn't really matter, also because the average time taken here is 0.15 milliseconds. That's no time compared to the other inputs that we have, but it's nice to know that the missing method and the brute force method are actually quite similar. So now to get over to the set solving work, we already know if you have the inputs of what cards there are to solve them. That's pretty trivial. Well, how would you actually recognize the cards? I've done it using a pretty simple method. So we take a screenshot of the phone. First off, what I'm actually doing is taking a screenshot of my page. So I'm using a screen copy to put the page. You can actually, and I initially did do this through Android debugging, ADB, but the latency in ADB is like 1.5 seconds to take a screenshot and half a second for clicking input. So even if you want to click 3 points on the screen very quickly, then well, it's slow. So I'm actually just using my actual mouse, using my mouse in Python and taking a screenshot of this video to figure it out. But let's say we have we're presented with a deck. So I took a screenshot of the phone, and then I cropped the screenshot into like a dictionary which had the boxes. So all possible card locations. So one here, 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 for all 12 of these, but also for the additional spaces here, because if there is no set in these 12 cards, it will just put an extra 3 cards, and if there's no set in the 15, then it will put an extra 3, and then possibly again an extra 2 after that. So I can just, once with the screenshot, get all the cards using the get cards function, and we can see here these cards should line up with what is here. But how does it do this? Fairly simple. We go to the get cards function, and then we go to get card, and let's say we want to get card for the first one here. Let's copy this over to a new file. And then the box we want to use is equal to the box dict 0. So it's now detected that there's 3 red striped ovals. How it does it is fairly simple. So we get we convert the image into a gray scale image just because it's easier to work with, and then take the RGB value of the darkest pixel to figure out the color. That's very easy. And then threshold the image. So now when we have the threshold, we should go dot from array. We see something like this once we threshold it. So the black is the white in this image, vice versa. So once we've done that, we can then just put a seed and isolate the background to get the background. And the background here shows that there are 3 shapes. All you do is you take a strip through the middle of the shapes, and you see that it goes from 0 to 255 and 255 to 0. So all you need to do is count the number of times there's a step edge in the array, and then divide it by 2. So for each shape there's of course 2 step edges. And then to find out what shape it is, just calculate the volume and then divide it by the number of shapes that there are. So the oval has the largest volume, and then the squiggle has less volume than that, and then the diamond has even less than that. I was actually using like a more sophisticated method before, like comparing this to the actual shapes, but this volume method is much faster. Then we need to find out the fill of the shape, so if it's empty or not. So we can do the same for here. If we subtract the threshold from the background, then we just get the inside of the shape. So if it's completely black, then of course it's filled. If it's like this, striped, then it is, well, a stripe shape, and you just then work the volume out from that. So a filled in shape will have 0 volume. This one will have about half because the border is also. So you just work out the volume on the inside of the shape, and that's how you find out the shape. So we know the number of cards, so the number of shapes on the card, the color, the stripedness, and the shape. They're the 4 properties that we need to find, and that's how you find them. And then I can't run it too quickly on this computer because I'm also recording and my computer's fairly slow. But we can see here it will go through the deck and find all the sets. As you can see, it can run in as little as 4 seconds. I'll put the GitHub link to the code in the description so you can check it out yourself.